Okay, folks, I hope you gave this some thought. This is part 2 of our minimum distance problem, the river, the tent, and you. Now, if I take this line here and that point, and I tell the computer to construct a parallel line, it virtually just extends the line here. So I'm going to change that into a dashed line, so that we can see it's a construction. Then I'm going to tell the computer to construct the perpendicular over there. And then find the point where those two intersect each other. So what am I basically doing? Let me just construct the point of intersection. I'm looking at this point reflected in this line. Now let's see if it's the same thing. If I say that point reflects in this line and I transform it and I say to the computer reflect it, oopsie, I selected the line, I must double click. So this in this line, okay, construct or transform and reflect it. We will see it's that point down there. So if I now move my point along the river there, then we can see the point that I constructed where the two intersect are the ones that are moving. Okay, so the point where the reflection is not moving, and it shouldn't be moving because it is an invariant point. So what did I do? I produced this side, and I constructed another triangle over here. Now you can see that these two angles are way different. Those two sides we have decided are never going to be equal in a scenario that we're looking at here. So they could be equal, but it's got nothing to do with this scenario. So let's just check what happens here. If I now move along the river, okay, so I want to also measure this distance from there to the line segment here. So I'm going to tell it to, oopsie, let me just find that there and this here and find construct the intersection point. So I want to measure that distance from there to that. Now remember, this is the reflected point for you. Okay, so I measure that distance, that's u prime because it has been reflected. Okay, so I've got the reflective distance there. That distance is given to me as 3.54. So if I move this up now, sorry, I shouldn't be moving that up, I should be moving my point along the river. Okay, if I move my point along the river and I see the difference that's happening here in terms of this distance, I'm at 17,477. If I continue to move that point there, I'm on 17,476, 587, 548, 519, 501, 494, 498. There we go. So the distance is, by the looks of it, at the reflexive point, where this point has been reflected. So the distance from the tent to the river to this line where I've dropped the altitude, it's got nothing to do with it. It's got to do with that point being reflected in this line, the river bank. And that will be the point that you calculate where you've got to hit the river. Okay, so it's got to do with the reflection over here. Now again, you can see that those two angles are very close. Okay, so that's the big hint here, the big takeaway for this problem. Go and think about it and start formulating an argument now, and keep on working.